80 milliliters. 80 milliliters, 0.1 molar, NaOH. Mice chart. H2SO4 plus NaOH. Two of them. 0.005. And if you're following along, 80 milliliters to a 0.1 molar solution is 0.008. If you need to do the calculation, keep doing it. Okay, so still 2-to-1 ratio, so 0.008 moles times our 1-to-2 mole ratio. It's the same mole ratio I've been doing. I'm now getting lazy. So this is 0.004 moles of H2SO4. So this all decreases. This only decreases by that much. But again, if you're paying attention, this is the 1-to-2 ratio right there. 0.004, 0.008. The 0.001 moles is what is left over. That 0.001 moles is now in 50 plus 80 milliliters of water. So 0.001 divided by 0.130 liters. That comes out to be 007, which comes out to be a pH of 2.11. And that was molar. Okay? I'll put all of these into the chart when we're all said and done. Okay? So, next one. Go to 100. So 100 milliliters, 0.1 molar, NaOH. So, mice chart. H2SO4 plus 2 NaOH. I am sure you guys are no longer drawing mice charts, but you need to be. 0.005. 100 milliliters in a 0.1 molar solution comes out to be 0.01 moles. So 0.01 moles. Ooh, this becomes interesting. Okay, because now I have my 0.01 moles of NaOH times my 1 mole of H2SO4 to 2 moles of NaOH, my 1-to-2 mole ratio, which doing this math means we come out at 0.005 moles of H2SO4. So this is all going to decrease and go to 0, and this is all going to decrease and go to 0. We are at the equivalence point. Equivalence is, all right. Don't go with my spelling, I'm an idiot. We're at the equivalence point. So we can't do any math. So because we can't do any math, you just have to know the pH is 7. Okay? I can't take the log of anything, I can't do anything. So you just have to know pH is 7. So because of that, what we're going to do is we're going to back up 1 milliliter. So we're going to go to 99 milliliters of my 0.1 molar H2SO4. And we're going to see what happens to the pH at that point. So right before the equivalence point. So, fun mice chart. H2SO4 plus 2 NaOH. Ooh boy. Ooh boy. Okay, so we're at 0.005, and so now we're at 0.1 mole per liter times 0.099 which means liters, which means we're at 0.0099 moles. So 0.0099 moles is where we're at. Okay, so we need to do some stoic. So 0.0099 moles of NaOH times my 1 mole of H2SO4 to 2 moles of NaOH. And that is going to come out to be 0.00495 moles of H2SO4. So this is still going to decrease by 0.0099. Okay, all of that goes away. This is going to decrease by 0.00495, leaving me with 0.0005 moles. So we still have moles of H2SO4 left. So the moles of H2SO4 that are left, 0.0005, are now in 50 plus 99 milliliters of water. So 0.0005 divided by 0.149 liters. Okay, and I didn't do molarity, so you can calculate the molarity, and then your pH on this one comes out to be 3.47. Okay, so even at this close, we're not at 7. Okay, we're only at 3.47. So what do? We're going to go up to 101. We're just going to see what is the pH right on the other side of 100. So 101.1 molar NaOH, all the same jazz. Sounds like a good movie. All the same jazz. Oopsie daisy. Getting too ahead of getting ahead of myself. This is getting long. I would fast forward if I were you. Still 0.005, except we do get an interesting development now, because this is now 0.0101 moles. I hope I don't have to show you how to calculate that anymore. You should be able to do that. But one of the things that you now see, or should see, is this is the limiting reactant now, which means we need to change the math a little bit. So at this point, our math changes. Okay? So what happens is we gotta actually start with the 0.005 moles of H2SO4, and we have to multiply that by 2 moles of NaOH per 1 mole of H2SO4, which means this comes out to be 0.01 moles of NaOH. And what you should see is that is now smaller than that. So that means this decreases by 0.005, because that is all we used right here. That's all we used. Okay? So then this decreases by 0.01, which means we have 0.0001 moles of base. OH minus ions are left. Okay? Which means we are going to calculate POH at this time. So you have 0.0001 moles of hydroxide ions that are in 50 plus 101 milliliters of water. So 0.0001 divided by 0.101 liters. And math-wise, I did not do the math. I just have the pH. I don't have the pH. I have to do the math. Hold on. Hold on. Hey, are we having fun yet or what? I gotta love titrations. So this is 9.9 times 10 to the minus fourth. We're going to go log second answer, which is which is an OH minus of 3.00, which is a pH then of 10.99. And that doesn't seem right. Oh, because I did not divide right. Oh, good gravy. Why didn't you tell me? Made a mistake in addition. 50 plus 101 is 151. Oh, bad boy. If you actually watched the video to this point and you caught this, I am going to give you a +1 smiley face. Good job. Can you tell I'm going a little batty at this point? I'm sure you are too. This comes out to be 6.62 times 10 to the minus fourth. Log second answer. POH 3.17. pH 10.82. Ooh, rocking and rolling. So, from this point on, the H2SO4 becomes the limiting. We're going to do one more because this has got to be a 20-minute video by now. And if you haven't fast forwarded through it by now, you're crazy. But we will do one last one just to show 120 milliliters, 0.1 molar NaOH, ice chart. Oops. This is going to be 0.012. Limiting excess, this is going to decrease by 0.005, which gives me 0. And this is actually going to decrease by the same exact amount every single time. So this is going to decrease by 0.01 every time, because if you take 0.005 times the 2-to-1 mole ratio, you'll only get 0.01 every time. So this is 0.002 moles of OH minus. That 0.002 moles of OH minus is in 50 plus 120 milliliters of water. Find the molarity and then find the pH. Find POH first, then find pH, and I get 12.07. Okay, so that's how you do a diprotic. Okay, the last thing we should do is graph everything. So I'm just going to come over here. We've already done 20. So at 40 milliliters, we were at 1.47 pH. So 40, 1.47, right in there. At 60 milliliters, we were at 1.74. So 60, so you know, we're not creeping up here very fast, are we? We're at there at 80 milliliters, we're at 2.11. We just, so at 80, we just barely crossed the 2 zone. So we're right in there. And then at 100, we go up to 7. So at 100, we're at 7. So that's where we backed off, and we did 99. And at 99, we were 3.47. So even at 99, we're only roughly somewhere in there. Okay, and then we did 101. And at 101, we were 10.82. So look at the jump. Okay, right on the other side of this, okay, we're at 1.82. Then we did 120, and at 120 we were 12.07. So 120, we're starting to flatten out again. And then at 140, which I didn't do, we're at 12.32. So 140, 12.32, so we don't even get much higher than that. So we have here a titration curve that jumps dramatically and then is going to flatten out. This point right here is our equivalence point. Strong acid, strong base titration curves tend to look like this. Okay? Good luck with your worksheets. Call it a day.